Hello everyone, welcome to the data pre-processing lab session. So in this lab, we are going to practice the different methods are available in Pandas to clean the data, to pre-process the data. Sometimes when we receive the data in real world, the way that data is stored in files or databases may not be in right format, or maybe missing values or improper values. Okay, so there are a lot of things are there when we speak about data pre-processing. All these things, like all this inappropriate data, needs to be converted to the right form, which is called data pre-processing. In data analytics, when we initially like apart from data loading, after data loading, the main thing that we will deal about is data cleaning. Okay, data cleaning, data transforming, rearranging the values, or all these things are known as pre-processing steps. Okay, so actually, these steps, pre-processing steps, takes up to 80% or more than 80% of the efforts goes to data pre-processing. Okay, so along with Python's inbuilt functions, Pandas provides high level and flexible and efficient tools to enable you to manipulate the data and clean the data, pre-process the data, and convert it into a form that you can use for analysis. Okay, anything analysis or visualization, or you're going to apply it in machine learning models, whatever it is. Pandas has a lot of built-in methods to clean the data, pre-process the data, so that you can use it in a way that can be converted into information. So in this particular lab, we are going to practice how to handle missing data, how to handle duplication of data, string manipulation, and some other analytical data transformation related methods, okay, related techniques. So first, let's deal about missing data, how to handle the missing data. So missing data occurs commonly in many data analysis applications. So when cleaning up the data for analysis, it is often very important to see whether there is missing data. Okay, so because it is itself a data, like what to say, it's a potential problem. It will result in lot of potential bias related issues because of the missing data. Okay, because it will be replaced with some other inappropriate format that may affect the total analysis. Okay, so first we have to look at the data and see whether there is any missing data. If there is any missing data, how to handle it, how to fill it, or whether we need to remove it or fill it with some standard values. Those are the things that we have to decide. So Pandas use the float in NaN, not a number, to represent missing data. Okay, so we call that as sentinel value, which can be easily detected. NaN value in Pandas using Pandas, you can easily detect the NaN value. First, let's import libraries for this. Import, we're going to use NumPy and Pandas. Let's import the libraries. Let's create a variable data frame. Okay, not a data frame, series. Okay, PD dot. I'm just creating a series with some missing data. So for creating missing data, I used NumPy. np.nan automatically creates not a number value. Okay, so I have included intentionally, I have included some not a number thing, and let's see how the series looks like. Okay. Okay, so we have red, blue, and the third value is intentionally not to see. You can see how it is getting replaced, not a number. Okay, so we are going to check. It's a very small series or data frame. You can just visibly, you can see that it is that. But if there are thousands of rows, thousands of values of that, how can we check whether the data set has something as not a number. For that, there is a method called isNull. We know that the isNull method will help you to figure it out. So isNull method, when it is applied to series, it says for each value, for each element, if there is a value, it will say false. When there is not a number, then it will say true. Okay. So the built-in Python, none value is also treated as not only not a number, the none value in NONE, that also will be treated as null, right? So for example, let's add in the storing data, let's change the value of red to none. How can you show that? When you assign it with none, okay, so I have assigned, let's see how the series looks. Now with this, you can see it has none and not a number. So when you apply the isNull method now, you can see both none and not a number gives true for null and false for the real data, the actual values. Okay, so it gives true for none. So what are the other methods that is related to this missing data handling? isNull will drop NA function will deal with this. Maybe with this. The drop NA, fill A is null, not null. So these are 4 methods which will help you to deal with missing data. So what drop NA method will do, it will filter access labels based on whether the values or for each label have missing data with varying thresholds for how much missing data that we can tolerate, like we can allow. Fill NA, what it will do, it will fill in the missing data with some given value. What you can specify with some value using an interpolation method or F fill or B fill, okay, forward fill or backward fill. isNull method we have already seen that will return Boolean value, true or false value, if it identifies null, missing data. Not null, it means negation of null. If you apply not null here, then it will give false and false for this and true for this because it is not null, it has some value. Okay, so next we're going to see how to filter out the missing data. Okay, how to filter out missing data. While you always have the option to, like, you can filter out that by using isNull method, you can do that. But there are other methods out there. You can just filter out the value by just use isNull and select the location, and then you can clean it. But there are other methods as well. Okay. So first, let's import a package from NumPy called NAN. Okay. So let's import that package. From NumPy, import NAN, and we are importing it as NA. Okay. So now let's create a series. Okay, series with values 1, and we are importing not a number. So how we have imported not a number like NA, right? So wherever you need not a number value, you can use NA there. So it will be the not replaced with not a number value. NA and then 7. Okay, so here we are going to use the drop NA method. Already we have seen the drop NA method before, right? So the drop NA method will remove that not a number automatically. For example, let's apply it here in this data series that we have created. Okay, data dot drop. You can see the method drop NA method. So what it will do, it will automatically remove all not a number options and just gives you the values. So filtering missing values in data frame. What are the other options? In series filtering, we have discussed all these things with the series, how to use seasonal function, how to use drop in a function. Let's apply all these things in the data frame. Okay, so in series, it is easy, it is single dimensional, but when you deal with the data frame is nothing but multiple rows and columns will be there, right? So you may want to drop rows or columns that are all not a number, or only those containing not any NAs, particular row or particular column. Okay, so drop NA by default, drop any row. It will consider the row for a default option. Okay, if you want to do the filtering operations in columns, then we have to specify it separately. Okay, let's see how we can use the drop NA in data frame. Let's create a data frame. And copy the data for creating this data frame. So I have intentionally, I have added some NA values here, NA values here. Okay, now let's see how the data frame looks like. You can see with all these rows and columns. Okay, so the drop NA would remove both column and equivalent row, right? Let's see. Let's create a variable. Drop NA function. We are going to apply drop NA. Okay. Okay, look at this. It removes everything. Okay, even if there is one column, all the other columns has some values. Only this column has NAN, but it will still remove the full row. Okay, it will remove full row. And we can specify, we can control, we can specify how to filter it. Whether you want to filter even if it has one single NAN, or you can say that only if it is more, or when it is all columns or NAN, you can specify it. Okay. So for example, if you use the how attribute with all value, then it will consider to remove the row, to drop the row when all columns have not a number. Okay, for example, let's say drop NA. What attribute? How attribute. How with the value, you have to specify the value all. So it will look for the row which has all columns NAN. It will remove only when all the columns has NAN values. It will just consider other rows. If it has one or two rows or NAN or columns are NAN, it will still consider it. It will be very strict. If not, it is kind of lenient in considering the property one or two values. Okay, it will just remove it when all the columns have not a number. For that, you have to use all. Let's create a new column. Okay, with not a number. Let's create a new column, data 4, where we're going to assign not a number for all the rows in that column. Let's see how it looks like. You can see I have created a new column where all the rows in that column has not a number, the last one. Okay. And now I am going to see how I can remove this. We have seen how to remove all the columns that has a particular row which has all the columns, not a number. To do this in the column which has all the rows as not a number, how to do that? Same thing. You can use how all. Okay, the only thing you have to use the attribute. Axis 0 means row, axis 1 is column. That's the case always. Axis 1 means column. You can see now we have removed that last newly added column by saying axis 1. So consider the column which has all the rows with not a number value. Okay, so that is how we can work with columns. Now we are going to do thresholding. How we can do it with thresholding? How to draw values or rows or columns with threshold values. Suppose you want to keep only rows containing a certain number of observations. You can indicate this with a threshold argument. Argument value is thres. Okay. So thres takes integer value which tells minimum amount of allowable NA values. Okay. So it will just mention how many rows, how many a minimum amount of NA that we are going to drop. To try this, let's create a data frame. Okay, let's create a data frame and see how it looks like. Okay, with some random floating point values we have created. And we are going to include some not a number things here. We're going to intentionally add some not a number. So that I'm going to use location ILOC where 4 rows and then 1. Fourth row in the first index will be NA. Fourth row in the first index will be NA. Okay. And then again another ILOC method where I'm going to say until second row in the second index will be N. Until second row in the second index will be NA. Okay, so you can see until a fourth row in the first column will be not a number, and in the second column until second row it is going to be not a number. We have just inserted some not a number values here to play with. Now we're going to apply drop number, drop NA. Okay, let's see whether it removes everything. Yes, it removes everything because even whether it is 1 or 2, it removes everything. Okay, now we're going to apply threshold, thres method attribute. Drop NA has an attribute called thres NA, which will help us to control this removal. Okay, for example, drop NA. I'm going to use thres 4. Okay, only when all 4. Okay, thres that is in column. That too, we are going to specify. We are going to work with the columns. So what will happen? It will just remove the column, the whole column, which has NaN values more than 4 or equal to 4. Okay, equal to 4 or more than 4. That is the threshold. So you can see it just remove column number 1 and keeps all other columns. Okay. So if you want to do it in the same thing in the row, how can we do that? In the row, we don't have more than 2 columns, only 3 columns are there. So let's say df drop NA. So we have only 3 columns. So let's say the thres value as 2. Okay, so when we don't specify any access attribute, then it will be by default row. It will consider the row, right? So here it considers the row, where you can see when there is more than 2 NAS, that is this column, this row will be deleted and this row will be deleted. 2, 3, 5, 4, 5, 6 will be considered. Okay, because you have specified 2. So 2 and more than 2 will be deleted. Okay, so this is how the drop NA will work. So we have just discussed drop NA method and all other attributes that is related to drop NA method. Okay, so far we have discussed about finding out the missing data and how to remove that by using drop NA method. Next, we'll see how to use fill NA method to fill those missing data. Okay, so rather than filtering out the missing data, most of the times we may need to fill those missing values with any kind of data. There are a number of ways that we can deal with that. Okay, we're going to see what are the things, how we can fill it, do we need to use random value or a filter or a specified value or the value of the previous rows or columns, how to deal with that. For most purposes, in most of the missing data problem, the fill NA method will be mostly useful. Okay, so it's useful in many occasions. Okay, to handle the missing data. So what are the methods are there? The fill NA method. Fill NA method has few attributes that will be really helpful. How to select the attributes according to the need. For example, value attribute, it will help you to select the scalar values or dictionary object to fill the missing values. Method attribute, where you can specify the method in which way that we have to fill, the forward filling or backward filling. Okay, there are multiple method values or the values of that for this method attribute. Okay, so by default it is row that we know. Axis 1 means column. Okay, for the data frame. In place, it will modify the calling object without producing a copy. Okay, it will just do the change in the original object itself. Limit, for forward and backward filling, maximum number. It will just give the limit when we do forward or backward filling by using the method attribute. Okay, so maybe let's use this previous data frame that we have created to apply some filling method. Okay, so let's use the df, and the method is tab fill NA. You can see fill NA method. Okay, fill NA method, and what I'm going to do, scalar value. Let's see the first thing, the scalar value. So when you say 0, then all the missing value will be filled with 0. Okay, if you want to do that with the value attribute, you can do that with value attribute as well. Fill NA, simply specify it, or you can use the value attribute that will help you to specify the scalar values. So now all the not a number values are filled with 1.0. Okay, you can give any values by this value attribute, using this value attribute. Calling the fill NA method with a dictionary, you can use different fill value for each column. You don't need to use the same value for same. We can say that for the first column, fill this 1.0. For the second column, fill 2.0. Like that, you can specify, customize the filling for different columns. Okay, fill NA method. For the first column, we're going to fill it with 0.5. Okay, dictionary like attribute. And then say the second column, we're going to fill it with 0.0. Let's say 0. Dictionary. So it's a dictionary, right? So I forgot the curly brace. Okay, so you can see the first column is filled with 0.5 and the second column is filled with 2.0. Okay, now you can see the original value is not affected. You're only working on the copy. Okay, now if we do in place, I told you the in place is the attribute that will change the original data as well. So let me use the in place attribute. Fill NA 0 in place true. When you set in place true, okay, it just fills everything with 0. Okay, here I'm saying the value should be filled with 0. When I set in place true, the df value itself, the original value got changed. So reindexing method can be used along with fill NA method. Fill NA, okay, the reindexing. For example, let's create a data frame. 6,3. Let's see how it looks. Okay, 6 rows and 3 columns. So now I'm going to assign some NA method. Okay, for all rows after second index in the first column and rows after fourth index in the second column. rows after first in the first column after second row, fourth in second row. And then for the second column, I'm going to use for the second column rows after the fourth index. Okay, when you specified :2, then before 2, when you say 4:4 after that column, then after fourth row, everything will be not a number. So you can see first column after fourth second index, the second column after fourth index. Okay. So now we are going to use the method attribute. In the fill NA, we have seen different kind of attributes. Now we are going to see the method attribute. So the method attribute can have many possible values: ff, fill, vfill. Okay, let's see one by one. Df dot fill NA method, fill NA method, and then the attribute name is method. Attribute name is method, and then forward fill. Forward fill. You can see forward fill. So what happens here? After 0.36701, that will be replaced for all not a numbers. And here, all the remaining values will be filled by 0.31, 0.321. Okay. So if you use forward, when you use forward fill, you can even limit how many values needs to be filled. Okay. For that, you have to use the limit attribute. Df dot fill NA method. Let's use forward fill. And for example, we want to do it only for 2 values, not for more than 2. We want to fill only for 2 rows. Okay. So in that case, you can use the limit attribute and say 2. You can see only 2 values got filled. And here also, there are only 2 values that has not a number. Even we can fill with mean and median values. Not only this forward fill, even we can use mean and median values. Maybe let's create a new data from series for this. Let's do it on series. So here we have created a series with 2 not a number values. So now we are going to fill these things with a mean value instead of 0 or 1 or any specific value. We're going to fill it with mean value. For that, fill NA data dot mean. You can see for 1, 3.5 and 7, the mean value is 3.833. So the all NAs will be filled with 3.833. Okay. So please explore Pandas documentation to see what are the other attributes are there in drop NA and fill NA. So in this section, in section 1, we just discussed about what are the importance of data handling missing data in data pre-processing. Okay, the methods drop NA method, is null method, drop NA method, fill NA method. Okay, how to use it both in series and data frames. So the main focus for this section 1 is how to use drop NA method and fill NA method to filter the missing data or to fill the missing data. Okay. So in the next section, I'm going to discuss about data transformation. Thank you.